All right, it says record, so hopefully we're in the right mode. All right, what we're going to be doing today is going to be really fun because we are going to be using the calculator to replace the algebra that we were doing before. Yeah, I know somebody likes that. I gotta get this up because I gotta be able to see it. All right, now this is one of the slides that I had up last week, and one of the things we had was that we were given the function when x was 5, and that function was given as 8. And then the function when f was 7, and that was 3.2, and we could find the value of the quotient of those 2 points. And so if we use the point 5, 8, and 7, 3.2, we found that the b, there's a b, the base multiplier, 2 times bigger in this one than this one. So we had an a and a b to the 5th, and the other one was an a and a b to the 7th, and when we divided them, I'm going to take 8 divided by 3.2, we ended up with what the b squared was. All right, so with your calculator, take 8 divided by 3.2. And you have 2.5. Now, that is the b. So we have 2.5 to the x power times a, and we have to find what the a is. All right. Now, if this equals 8, when this is 5, how do you find that? Take 8 divided by 2.5 to the 5th power. So 8 divided by 2.5 raised to the 5th power is 0.08192. So the equation of this whole thing will be f of x equals an a of 0.08192 times the b, which was 2.5 to the x power. All right, that becomes the equation of the whole thing. And the algebra to get that was just basically replacements. Okay? All right, so we learned something, and this was the way that we calculated these things 2 years ago. Okay? Now, what we're going to do today is we're going to use stat.
I love stat.
We're going to use stat. Now, in the 2 problems that we had 5, 8, and 7, 3.2. All right, so press stat, and guess what we want to do? Edit. So go to 1, and then we want the x values to be 5, enter, 7, enter, and then we go over to the y values, and it needs to be 8, enter, and 3.2, enter, and then everything else should be cleared out. So you have those 2.
Right here.
Go to the L1 at the top, click clear, and then go back down.
Yeah. The easiest way, if you got a bunch of them, is what he just said. Go to L1 up to L1, press clear to clear the whole thing because you only got 2 to do. You can also get on individual ones and press delete if you have just a couple of those too. All right, okay, so now we have the 2 points that we did, or that I just did the other calculation on. Okay, so now we're going to go back to stat, go over to calc. Now, if you'll notice down with your 9 you have an arrow, that means there's more of them. So press your down arrow until you get to number 10, which is exponential. Press enter. Bring up the equation, get down to calculate.
Okay, I'm still looking for calc for some reason. I can't find it.
Second calc is over 1. Wait a minute, go stat.
Oh,
Stat. All right, now, calc.
okay, that's it.
So you go down to like, it's EXP, right? Exponential.
Yes.
Okay. Oh, yeah. Okay.
All right, and with that, we get an A of 0.63. All right, we had a 0, and then we get 79.0, I'm sorry, the A is 79 and our B is 0.63. And I think when I did this before, I think I did it with the numbers reversed. Because it should have been 3.2 divided by 8. And I took 8 and divided it by 3.2. So that's the reason that they didn't come up correctly. All right, so let's look at 2 more. All right, this was 79.0569 times a B of 0.6324 to the x power. All right, let's go in and let's work these two, f of 1 and f of negative 1. So go back to stat, edit, and the x is going to be 1, enter, and negative 1, enter. And then my f of 1 is 50. And my f of negative 1 is 125. Okay, now I've got them entered. How do I get the calculations? Stat. Calc. And then all you have to do is press 0, and it'll bring it up, because 0 is the 10th. And again, you have the... Cool, all right? Now we can go to the textbook. And see which one we want to do. Let's look at problem 2 in the textbook on page 303. All right, let's see a rabbit problem. See if I can get a... Okay, so in the rabbit problem it says that assume that there were 60,000 rabbits in 1865, okay, and that there were 2,400,000 rabbits in 2 years later. So the first one is the start year, which is 0, and there were, let's do it in thousands, let's use 60,000. Now we could put all the zeros in, but, and then the second one, it says 2 years later, it's at 2,400,000. So 2 years later, it's at 2,400,000. Let's put the zeros in just because it'll make it easier. Calculator doesn't care. All right, now, what do I do to find the equation? If this is exponential, go to stat, edit, 0, enter. And now I want 2, enter. Oops. $60, 1, 2, 3, and 240, 2, 3, 4. Notice the calculator, in my calculator changed the L2 number to an exponent or scientific notation. 2 times 10 to the 6th, 2e6, 2 times 10 to the 6th. Right. That's one of the reasons I didn't want to do that, but it works out. Okay. All right. Now we have that. And how do we find the equation? Stat, calc, 0. Drop down. All right, so we know that the A is 60,000, and then the B is 6.3246 to the x power. Okay, now, how many rabbits will there be in 4 years? Yes.
I have B is 2.
You had what?
I have B is 2.
Go back and look at your stats. When you press stat edit, what do you have?
0, and then 60.
0, 60,000, and
2,400,000. 240, 0, 0, 0.
Oh, you have to do. You're short of 0. That's why they come out. All right. There's 24 followed by 5 zeros. Yeah. When I changed it, Josh, we had 2,400. I had to add 3 more zeros. You just added 2 more.
Oh.
That's why the numbers didn't work out. Okay. So now if this is my equation, we have 2 choices. I can put this into y equals. And then I can use the table to find values of whole number years. Or I could simply put this in the main thing and replace this with a 4. All right, but let's go to y equals. Now I've got to clear a couple out here. All right, in y equals, let's put this equation in and let's see what the graph looks like. So 60, 1, 2, 3, times 6.3246, and then raised to the x power. And my graph looks like that.
Will be about 9.62 times 10 to the 7 power.
All right, okay, now, there's 2 ways. There's 2 ways to find how many in 4 years. Because we have this in, we can do second calc 1, and we can put in the value for x. So go to second calc 1 and change the x to 4. At the bottom you'll see your flashing cursor. Enter 4, and when you press enter, you get 9,600,000 rabbits. That's what the y will equal. All right, see that? All right, any questions on that? Did you get that, John? All right, you go to, it's already in the, this is in the y equals, so go second calc 1, which is value for x, and we want to check 4. All right, and so when you do that, you have the x of 4, and then I had to count the number of 1. Yeah, no, it's 96 million, isn't it? Yes. It's 96 million rabbits in 4 years. Okay, I love rabbit, by the way. Okay, now here's another way we could get that. Did you get it, Josh? Excuse me just a second. Okay. All right. Oh, okay. All right, you got it. Second calc. calc right here.
Second calc.
Second calc, you want one value. One. And now press 4 there. And there here. Except you still have that number different. But don't worry about that now. Okay, now, all right, second way that you can do that is to do table. Because we have in y equals, so go second table, and if you'll notice you have some x values there. If your x values are already in the area, you notice that it says 9.6 E7. That's 9.6 times 10 to the 7th, huh?
I have that.
Okay. 9.6 times 10 to the 7th would be 9, 7, followed by 6 zeros, which was the, oh, I'm sorry, 96. 96, which was the 96 million that we talked about before. Okay? All right, so what we're doing is that we see the basic form that used to have to do by hand because we didn't have a graphing calculator. So now we have a graphing calculator, so we're going to use stat to be able to create, or to be able to let the calculator find what the equation looks like. Then we're going to put the equation into y equals, and we should be able to do any of the other questions that are asked. Okay? All right, so now let's turn over, let's look at 3. Okay? All right, so he is at 64 kilometers when the car runs out of gas. As he slows down, his speed decreases exponentially with the number of seconds since he ran out of gas, dropping to 48 kilometers per hour after 10 seconds. So I know that one of my numbers is 48 kilometers after 10 seconds. Okay, now, he started at 64 kilometers, 0 seconds after he ran out of gas, or 0 seconds before. Okay, so now we have 2 points for exponential equation. So how do we do it?
Calc 0.
Okay, so we're going to put in 0.64 and 1048, and then we're going to go stacked, calc, 0. Okay, check your answer with what I just wrote on the board. And I checked it with the book's answer, so I'm good. Are you good? Okay, now, so all right, now that's the equation. Where do we need to put that so that we can work with it? We want to put it in y equals. Okay, now it says, what is the speed after 25 seconds? All right, now I know that my my calculator, if I do table, is not going to be around 25. So I'm going to use second calc and then 1 value. And I'm going to make it x to 25.
I got a number around 31.
31.17, right? So when f is 25, we have 31.17.559 kilometers per hour. Okay, now, here's the second question. At what speed, or how many seconds will it be for him to be, because he started at 64 kilometers, to be at 50 kilometers per hour? All right, in this case, you want a y of 50. Now you can find that off the table. All right, so go second table and look at the arrows. All right, take your arrows down until you see the y, and it will be between how many seconds? When he's at 50 kilometers per hour.
8 and 9.
Between 8 and 9 seconds. Yeah. Now, suppose that you wanted to be more accurate than 8 and 9 seconds. All right, go to second table set. Second table set. All right, what we want to do is we want to start that table at 8, because it's between 8 and 9, and the delta table we need to set to 0.1, so it will change it to 1/10 of a second. Instead of jumping every second, x going every 1, we'll start at 8 and drop it to 1/10. So let me get that 8 and 0.1. And now when I do second table, I can get even closer. And it looks like it'll be between 8.5 and 8.6 seconds. All right, now, that's 8.5 and 8.6 seconds. Suppose I wanted it even closer than that. Go back to table set. Change the start to 8.5. And then change the other one to 0.01. And now when we go to table, we can find that it will be 8.58 seconds. See it? Question? Emery, you got it?
Just about.
Okay. All right, 8.58 seconds is 50.001 kilometers per second, right? Which is pretty close to finding it where it's 50 kilometers, right? Okay, so the table set, when you get close, you can refine it, make it finer by doing that. Okay, so let's go back again. Go back to table set, and let's change the start to 0 and change the delta to 1. All right, and then let's look at the graph. So jump to the graph. And now do second table, look at the table. All right, those are all whole numbers jumping x from 1 to 2 to 3 because that is the change of 1. Now, where is the 50 located? All right, the 50 is located between 8 seconds and 9 seconds. So to get closer by a 1/10, you would go to second table. All right, let's do that again because this may be new to you. Go second table set, which is where the window is. Change the start to 8. And then the table change to 0.1. And now when you go to second table, it starts at 8 and you have 8.1, 8.2, 8.3. All right, and I see again that 8.5 is close. So if I wanted it closer than every 10th, I could go do that table set one more time. And obviously, if you wanted it even closer, you could go down to hundreds and thousands with that same process. Okay, so what we've done in the lesson so far is that we've seen that we can create, after we find the 2 points, that we can create the equation using stat. And then when we put the stat in y equals, we have tools for table that will be able to get us to whatever the y value is. We could use second calc 1 to find a particular x. And then we're going to use second table and look to find a particular y. Okay? All right, so let's look at problem 5, just because it's there. Okay, it says Phoebe's is out Sunday driving in her rocket ship. She fills up with fuel, and when she starts the last stage of her rocket, she is going 4230 miles per hour. 10 seconds later, she's going 6850. So it looks like we have 0 and 4230 in 10 seconds. I get the numbers right. 4230 and 6850. All right, see that? All right, so if that's the case, while the last stage is running, you assume that Phoebe's speed is increasing exponentially with time. Okay, so the first thing we want is an equation. So how are we going to find the equation? Stat, edit. All right, double check your calculation. It look like that? Okay, so this is the start, and it's increasing about 5% per second. Because if you look at this number, 100% would be 1.000. So this is 4.9% increase every time x increases. All right, so it would be basically 5% per second. All right, if we're just interpreting this. Right, and so if this number is exponentially increasing, this base number has to be above 1, or if it's less than 1, then it will be an exponential decrease. All right, so let's say that I was doing something different, like the speed that we stopped at. Let's say that the B number is 0.981 to the x power. This is a 1.9% decrease because it's 0.19 short of 100%. Right? So this will be a 1.9% decrease And this is a 4.9% increase. All right, does that make sense? Now that wasn't part of the lesson, but that's a good analysis that you should be able to figure. Okay? All right, so now what do I do with this if I need some math work? I've got to put this in y equals. Let's go to y equals. Right now, after we put this in, the last thing that we did, if you remember, we had an x that was on 8. Right? Okay, so if you wanted to check an x of 20, how could you find the answer?
Do the table set.
You could do table set, or you could do second calc. All right, so let's go second calc. Second calc. Number 1 is the value for x. All right, when you press 20, it gives you 11,000. I don't know what the units were. Was it feet or miles?
Yeah,
Miles per hour, yeah, because it's a rocket ship. So he's doing 11,000 miles per hour. All right, so we can find it that way. If we went to table set, let's go second table set and just set the table to 0, and then don't forget to change the delta back to 1. Because you want the x's to be, oh wait a minute, here's something here. Suppose that you needed 1/3. Then you could do the delta at 1 divided by 3, and it would give you the 0, 1/3, 2/3, next whole, 1/3, 2/3, next whole. All right, and you can do the same thing with fourths if you wanted. So you don't have to do it with tenths. Okay? All right, so now when we do that and we go second table, we have the small numbers. Okay, now all right, I'm going to do a second one for you, and I want to see if you can do it. I want to know exactly 5,700 miles per hour. I want to know when is it exactly 5,700 miles per hour. I'm almost there. You get that?
I got 6.187, and I got.
All right, I got at 6.187. I have 5,700.4, but at 6.186, I have 5,700.1.
For me, if I have 6.187, I have 5700 and no decimals.
What did you use for this up here? Did you have?
I think 1.04939.
Oh, okay. All right. Okay, then that's our difference. Is that I rounded to 9 through round 4. You went one extra decimal place, so you have more precision than I do. All right. Okay. Do you stay with us? Okay. How far did you get, Josh? All right. Because I'm taping this, I do want to go over what we did. Okay. So we want exactly this. So we're going to go second table set. And we want to start at 6, and we want the change to be 0.1. And you really don't need 0.1, but it's okay. All right, so when you press that and go to second table, you'll notice that the 5700 is somewhere near 6.1 or 6.2. Because 6.1 is 5676, 6.2 is 5703.
I have 6.1 as 46.
Okay, did you change your, did you have this at 3.9 or 4 here? Look at your table, or at y equals.
I have 0.0494.
494, okay, and this is 4230? Okay, then you should have for 6.2, you should have 5703. Do second tables. It's the same thing. It's the same thing. It's just set up different. Okay, all right. Now, from here, if we do a second table set at 6.2 and set the table to 0.010 or 0.01, when we go to second table, we're just a little bit above it. So if we press the up arrow, we'll notice that we're between 6.18 and 6.19 for exactly 5,700. All right, and so that means I need 6.18, start at 6.18 and do 1,000, which is second table set. 618, and then change that to 0.001. And then I can find the 6.186 is the correct one. And I think maybe that you got normal. That's weird. I don't know why yours is doing that, Josh.
Can I take values out and see if she said something?
No, you can. But, okay. All right. Now, so that takes care of those values, and I think if you put that into practice, that will help a lot. Okay. Now let's turn over to page 318, and we're going to look at some of the chapter values. I've got this listed here. Okay. Oh, where's my mouse?
I'm just loving this chapter review.
Yes. Okay. Now, if we look at the chapter review. All right, R1 on page 318. R1 318 says, if you take f of x is 3 to the x power, and you have to find values of x. All right, let me see if I can do this. So put, I need to make this larger. T equals and y equals. All right, so what the first thing you need to do is put 3x into y equals. 3 raised to the x power in y equals. Now, how can you find 4, or f of 4, f of 3, f of 2, and f of 1? Use the table. So go second table. Now, when I did that, my first one is at 618 because I was working on that previous problem. So I've got to now go second table set and go back to 1 and then change my delta to 1. And then when I press second table, I'm at x is 1 and y is 3. And so now you have the values. Now, it also says show that, that f of 3 is 1/3 of f of 4. So f of 4 is 81. So when you take 81 and divide it by 27, you're going to get a multiplier of 3. That's all that means. And so if you started at 81 and went back to 27, you'd have a multiplier of 1/3. Okay, that's all that's saying. All right, and if you'll notice, all of them are factors of 3, but we knew that because to go from 3 to the x power, if you go from 3 to the 4th power to 3 to the 5th power, you've added 1 more 3 if you went up. So if you're going down, if you go from 3 to the 5th and go from 3 to the 4th, you've divided by 3. You divided by the base number, in this case 3. Okay? All right, now R2 says evaluate using the proper order of operations. That's all calculator work. If you put that stuff in the calculator like you see it, including the parentheses. By the way, at the end of R2, do you see the third power? How do you put the third power in besides raised to 3? Right. Remember math frac? Look at math. Look at math and then look at the third one. There, that's where the exponent of 3 is located. The exponent 2 is a button on the calculator. Math 3 will give you an exponent of 3, just like the squared is. And do you notice number 4 is the cube root? In case you didn't know that, in math frac, you also have some other math things that are real important. Okay? The bottom ones are used in calculus, so. All right, so anyway. Now, number 3 says, name and state the 5 properties of exponentiation. Okay, those are from the book. All right, it's talking about a power of a power, power of a product, power of a quotient. It's those things. All right, so you'll have to probably look those up. Now, R3B. All right, in Algebra 1 today, we came across this again. They were doing quadratic formula, and they were taking -3 to the 2nd power, and they weren't using parentheses. And so they were coming up with wrong values for doing quadratic formula because they were doing -3 to the 2nd power, which is -9, instead of -3 times -3, which is +9. So in problem R3B, the first number is going to be negative, and the second number will be negative because it's the third power, but the last one will be positive because there are 4 negative signs. All right, and then the rest of those I think are pretty straightforward. Okay, in R3D, how many extra 5s are in the top? 4. So 1,230 of them will cancel out, and there'll be 4 left in the numerator, which is 5 to the 4th. And then that should be a number, not just left as 5 to the 4th. All right, now, sketch the graph quickly of f of x equals 1.8 to the x power. All right, what happens when x is 0? What is 1.8 to the 0 power? 1. So therefore, 0, 1 is a point on the graph. 0, 1 is a point on the graph. When x gets to 1, 1.8 to the first power is going to be at 1.8, which is going to be right here. Right? And then this will hug, it'll go through here and it'll go up like that. So the asymptote is at the x-axis on here, and then this is going to go through 1, and then 1.8, and then twice, 1.8 times 1.8, whatever that is, and then it's going to shoot up as an exponential function. All exponential functions that do not have an extra plus b on the end of it will all go through 0, 1, because any number to the 0 power. Now, I can also move this. If this is b to the x power, suppose I did a minus 3. This is for college algebra. Minus 3, this line is right here, and that point will drop down 3. So 1, 2, 3. The point will be here, and my asymptote will now be here at the minus 3, and this point will now be right here. And that graph is going to look like this. So I can move it vertically with an extra number on the outside, but if this extra number is not here, they're all going to go through 0, 1. And that's my point for Algebra 2. They'll all go through 0, 1. And that's why it says in the book, that's why it says graph it quickly. Because those 2 points, now let me do it this way. What is the probable equation, exponential equation of that line? F of x equals, all right, if you notice when x is 1, y is 5, so it looks like it may be something close to that. Right, so check in and see if this is 0. Now, suppose that I had this. All right, let's pretend that's a halfway right there. That's halfway between those two. All right, what's happened to this? It's moved up 2, right? That means I have a plus 2 here, right? And when x is 1, I'm at a half. So that's going to change this. It probably won't be. I'm sorry. I meant to do that. This is 1 here, and this is 2. Okay. So when x is 1, I have 1, 2, 3, 4. All right, so just like this was 5, now this is 4, but I changed the scale here. All right, so you're going to find that you can move that that exponential function up and down vertically by adding a number on the outside. But you check where is the 0 and where is the 1. Okay? All right, now, R4. Find the definition, or definitions, I'm going to do that. All right, evaluate in E. All right, how would you put E, the first one, I, how would you put that in the calculator?
Just do 128 raised to, I usually do parentheses, 4 times.
Yeah, you have to put in parentheses. The newer calculators, all you have to do is 4 divided by 5, and then you have to exit out of the exponent. The older calculators, Josh, you have to put raised to parentheses. One of the improvements that they made in the TI-84 is they tried to shorten the number of keystrokes, and so that's the reason why in the newer ones, when you go to raise to, it keeps it in the exponent until you exit out with a side arrow key. Right? The older ones, you have to put the raised to parentheses. Now yours, I'm pretty sure, is raised to parentheses. Does yours exit out?
I don't need to do parentheses after your exit.
You don't have to, yeah. Okay, so, yeah, and what I didn't recognize was those two things on the face look the same. You know, but they operate differently because of the age of the calculator. Okay. All right, now, so that one works out good. All right, now, E double I. How do you get cube root? Math, right? Okay, it's good to know that one. If you didn't, the cube root is the 1/3 power. If you don't remember that you have under math, you have a cube root, it's the 1/3 power. Now, suppose that this problem had been the 5th root of 512. Now you don't have a choice. There's 2 ways you can do it. The 5th root is the 1/5 power. Right, so let's take, with your calculator, take 512 in the main screen. In the main screen, take 512 raised to the 1 divided by 5 power. And you get 3.4822. All right, now how can we prove, did you get it, Josh? Okay, how can we prove that that is actually right? Store to X. Store to X. And then we want to take X and raise it to the 5th power, and we should get 512. So X raised to the 5th, exactly 512. All right, and then the rest of E shouldn't be that problem. Oh, look at there, look at V. Look at number 5. E5, in R4 there is a 5th root. So we've already talked about how to do that. You can raise that to the 1/5 power. Now there's another one, and I'll show you this. Go into math. Look at number 5 in math. You see that X? Okay, but in order to be able to do that, exit out for quit. Put a 5 on your main screen, and then go to math 5. Now you have the 5th root of whatever you put in there. Okay?
You can also change, you can click over on the answer and you can change whatever you want.
Okay. Yeah, there's a number of ways, but yeah, you'd have to go backwards, is what you're saying. If you press that, it's going to leave you a little hyphenated box where the root is, and you have to go back and put the 5 in. Okay, now R5 says find the exact value. What is the exact value? What does that mean? What that means is that you're supposed to give the value as either a terminating decimal or as a root without that. Okay, so let's look at the first one. I know that 64 to the 2/3 power is actually going to be a whole number. So, but what is 64 to the 2/3 power?
16.
Yeah, it's 16. Now, let me double check something here. All right, all of those except, it says R5B does not. Okay, now, here's what happens. If you look at R5, you notice that the exponent is negative. See that? The exponent is negative. All right, if you have a negative exponent and you put it in the calculator will deal with it separately, because a negative exponent is not talking about plus or minus. A negative exponent is talking about where it is in the fraction. All right, and here's how that works. What is 0 minus 2/3? Or is that thirds or fifths? Hang on. 0 minus 2/5. 0 minus 2/5 is negative 2/5, right? Well, if you know your work, this is 1 over 2/5. We've got to see what the base number was. Base number is 32. So this is 32 to the 0 power, which is 1 over 32. And so where is this 2/5 if it's a negative exponent? It's in the denominator. So to get rid of that negative, I have to go 1 over 32 to the 2/5. All right, and so please remember that a negative exponent is not talking about plus or minus. It's talking about whether or not it's in the top of the fraction or the bottom of the fraction. Okay. And let's see what else. How close are we? Before we go to 30? I think we'll go 30? Okay. See, R6 is, now, in R6, what's 6 times 9? 6 times 9? So 54, right? So therefore the scientific notation is not going to be accurate, because the scientific notation, that first number has to be between 1 and 10, or 1 and less than 10. And so therefore you're going to have an adjustment when you do the multiplying. The same thing is going to be true in 6b, because 1.2 divided by 5 is going to be a decimal, 2 point something, 2.6. All right, and so therefore you're going to have to make an adjustment on the exponent with the 10 in order to leave it in scientific notation. C is probably not going to change, because I think 2 to the 3rd power, I don't think it's going to reach 10. If it does, then instead of being 10 to the negative 39, you're going to have to drop it down 1. It'll be negative 38. Okay? All right, second page, R7. All right, solve that without logarithms. All right, how would you do that if you had to solve that without logarithms? All right, if you're not going to use logarithms, what are you going to have to? You're going to have to use y equals. Right? So let's do this. Turn your calculator on. Go to y equals, and put in y equals 5x. And in the second equation, y equals 328. Because doesn't that say y equals 328? Right?
Yeah.
Okay. And so what we want is the intersection of those two equations. How do you find the intersection? All right. Yeah, the first thing you may have here, you're going to use second calc and number 5 intersection. Now the second one's not even going to show, but then you just press enter, enter, enter. And you have 3.599. It must be, probably average is 3.6. Did you get it?
Yeah, 3.6.
Okay. All right. So, but I think to be able to be accurate, I would use the decimal point. 3.55994. Now let's do this in the calculator. Go to the main screen, quit, second quit, and go 5 raised to 3.59994. And when you do that, you get 327.999, which is pretty close to 328. Okay, so what did you recognize in 7? Is that you have a calculator that can find the intersection of each equation, the one on the left and the one on the right.
Yes.
Okay, so now, watch this. I'm going to show you something that okay, here's an equation that you have to solve for x. If you put this into y equals in one, and you put this into y equals in another one, and find the intersection, that will be where x is the same value on both sides. And so instead of having to move it all and collect it, you can actually put that each side in the calculator and then do intersection. Second calc 5. Right, which is really what we just did. Right? Because we said f of x is equal to 5 to the x power, but we also said it was 328. And so I put this into y equals and this into y equals and find the intersection. You do the same thing right there with linear equation, and you might find it faster and more accurately than having to do the math by hand, especially if there were some other decimals involved instead of just one. Okay, now, that takes our Algebra II up to the college algebra level. Now, if we had to solve this by log, what would you do?
Divide through.
Well,
the log is 328.
All right, first of all, we reinterpret this to say log base 5 of 328 is equal to the exponent. And then what do I do with this to find the value of x. This is base change. Log of 328 divided by log of 5. All right, but the direction said you couldn't use that one. Okay? All right, now, let's see where we're at. All right, number R8. First step in R8. You got to get rid of the 3.79. What math do you do to get rid of the 3.79? You divide by it, right? You divide by 3.79. So that's going to change the right side. And then to be able to get at the 5x, we're going to take the log of base 0.41 of both sides. Because that's the identity rule. Log base 0.41 of 0.41 is 1. So that gives me 5x equals log of whatever 71 divided by 3.79 is. And then when I'm done with that, divide by 5 and I got x. Store it to x and then double check it by putting in the first part and you should get 71. All right, now to sketch that quickly, I don't know, let's see, I don't know how you do that quickly. All right, log of x just comes the other way. It's the opposite of the exponent function, but I'm not sure what they're wanting when they say quickly. Okay, next one, R9. Find J. Okay, change JA, or 9A, change it to an exponent. What's the base number? 27. Raised to what power? 2/3 equals J, so it's just calculator work after you change it. Okay, 9B. Right, that's base change already. Log 81 divided by log 3. All right, and then C. C is the longest one because when you do the base change, when you change it back to exponent, you're going to have p to the 3rd equals 343, and then you have to take the cube root of 343 to get p by itself. All right, and so if you remember when we first started logarithms, the 9C was the longest one. It took the most steps. The other two were just basically one in calculator. Yes, sir.
So it is.
Time? Huh?
It is temporary.
All right. Okay. I'm not sure what time to leave, but we're going to stop. Okay. All right. Thank you. All right. So the work that you're going to do is now notice that you're supposed to do R7 through R14. All right, plus 2 and 8, and use your stat for problems 2 and 6. Sorry, I said 2 and 8. 2 and 6, use your stat button. Get used to using that. Okay? All right, thank you.
Do you have stuff we need to turn in?
Yes, I think you do, and I'll collect that.